So, hello guys, and welcome to A.I.M Learning and Kaggle Days Meetup Surat. Today we have Ayon Roy as our speaker, and he is a data science intern at LULU Exchange, and he is also one of the speakers or mentors in one of the coming hackathons. And now over to Ayon Roy, who will be going ahead with this webinar.
Yeah, sure. Thanks to Manpreet and KDM Surat team for inviting me, right? Because it has been a pleasure for me to be a part of Kaggle Days Meetup community for a long time. So I am really glad that Manpreet took the initiative to start this thing in Surat. So at least now we have a new community in Surat, and I think the data science and machine learning enthusiasts in Surat would be having a good time. And it's now your responsibility, Kaggle Days Meetup Surat, to deliver at the level best, right? So that the community and members who are there in Surat can get most out of it. And today,
Yeah.
I would be introducing myself through my slides, right? So let me share my screen. If you can see my screen, just let me know, right?
Okay, wait. I'll share it.
So is my screen visible?
No. Yeah, wait. It is now.
Okay. So like I think that we are good to go, right? So
Yeah.
thanks to all of you for joining in, and thanks to KDM Surat for organizing this meetup on Sunday, right? And because coming up on a Sunday morning is itself a difficult task, right? Because you have been studying whole night on Saturdays and then waking up on Sunday at 11 a.m. is a bit tough task. So yeah, thanks to all of you for joining. And today I would be covering the topic machine learning pipeline with PySpark. So like you might have heard about machine learning pipelines, right? How things work from end to end. But what is PySpark? Or you might not have been familiar with PySpark much, right? So I will just give you a brief overview about what Spark is and why we are using PySpark, or what is PySpark, so that we can set the context for the session and we can just see how we can build machine learning pipelines with PySpark. So moving to the next slide. So this is my introduction. I am a fourth year student. Like I just passed my sixth semester in BTech Computer Science, and I'm currently a data science intern at LULU International Exchange, where I usually work into financial things like transaction, demand forecasting, things like that. And like similarly, I share the same goal at Kaggle Days Meetup community, right? So I brought the community for the first time in India. So we share the common goal, right? So this is the brief agenda about the day, like how we would be progressing ahead, how Spark's architecture will help us in doing machine learning. So maybe Spark is itself a big concept for you, but I will try my best to help you explain what Spark is, or how the architecture looks like, and how we can leverage the potential of that architecture to do machine learning. And after that, we have set that context of Spark, then Spark architecture, then how we can do machine learning with Spark. Then we would be trying to see how we can make a machine learning pipeline. Maybe you are familiar with machine learning pipeline in scikit-learn. Maybe you have used like these pipelines, or made some pipelines of machine learning using scikit-learn. But we would be using things like PySpark to make a machine learning pipeline. We would be covering two things. I would not be going into a hands-on session, because hands-on session would be a bit difficult into virtual things, right? So I would just give some resources and give you some tips, or give you some knowledge about two things: how you can make a machine learning pipeline using the already existing functionalities, and in case you want to make your own machine learning pipeline, maybe you want to make something which is not already existing in PySpark, or which is not already existing, so how you can progress ahead, or how you can see those things, right? So I would be covering two things. First is already existing functionalities, then how you can make your own functionalities, right? But before that, I would request all of you to just take a pen and paper, and if you want coffee or chai, anything like that, so that you can take up the notes, or so that you can put down your questions in the notebook. And once we end this session, we will just move ahead and take up your questions, so that you do not miss out your queries, right? Because maybe at till the end of the session, or till the end of the webinar, you may forget your questions. So just try to write down your questions, try to take some notes if it's useful, right? and like this is my suggestion before starting the session. And now this is the main base, right? This topic would be setting the base for the entire talk. Why I'm covering this is because usually Spark, if you have heard about, like I would give you a call, like I would give you a high level overview about Spark. So big data, right? Big data is a huge concept that's booming along with machine learning, data science, AI. But what's actually big data? Big data is which things are not the things which are not are not capable of being transformed or being processed in a single machine. Maybe you have petabytes or zettabytes of data which are not feasible to be computed in a single machine or a single cluster. So how we use big data? Big data is like parallel processing. You have those parallel processing going on, and you can divide your entire task into multiple parts, right? So you can do parallelly. Let's say you have you want to throw a party to your friends, and you are making some food at your home. But for a individual person, it's very tough to make food for 50 people. But if you invite a few of your relatives or few of your friends to help you out, you will tell friend one to do this, tell friend two to do this, tell friend three to do this. Then you can combine those things, right? So Spark works in the similar fashion, right? It divides those things, it does parallel processing and combines the result and gives you the entire final output, right? So this is how Spark works. And if you want to learn about Spark, because Spark itself is a big domain and like it's itself a big topic to be covered, so Apache Spark, you can just type about it and see like how big data and Apache Spark works. But our main agenda would be like how Spark's architecture looks like, right? Because if we cannot visualize how the Spark's architecture looks like, it would be a bit difficult for us to do machine learning. Because machine learning we can do, but we have to understand the architecture, how we can tune those features, or how we can understand those things, right? So this is how Spark's architecture looks like. I would just explain you step by step. So the basic step is Hadoop or Yarn. So big data have those concepts of memory distribution, right? Because how will the parallel processing work? Your computer doesn't have any knowledge, prior knowledge about how to divide the entire task into multiple parts, or how to instruct someone to do parallel processing. Your computer doesn't knows those things, right? So you can have those have these things, yeah, Hadoop, Yarn, or Amazon EC2. Like EC2 instances are like, if you are familiar with Amazon AWS, so you can just go and look about it, right? EC2. So you can have different distributed computing platforms or distributed computing setup, right? Apache Mesos, standalone clusters. You can also have standalone clusters. What does standalone clusters mean? It's like in your local machine only, you are dividing your entire processing, entire storage into different chunks in your single machine only. Like you may think that big data is related to like tens or hundreds of connected to a single server. That's okay. That's usually happening in some big companies like Uber or Facebook. But if you want to learn, or if you want to see at your end, so this would be a standalone cluster. Standalone cluster means same, like in a single machine you have all those distributions, processing, storage, everything is distributed in your local machine only, right? So that's a standalone mode. But whenever you are trying to learn, whenever you're trying to experiment with Spark, I would prefer standalone. And then you have Spark core. So these are data sources. Data sources means from where the data will come, right? Because machine learning or AI, whenever you talk about those things, if you do not have data, it's like you are missing something, right? Because the real essence of machine learning or AI is missing if you do not have those data sources, or if you do not have those from where the data would come, right? So these are a few things like HDFS, like this is Hadoop distributed file system, as we talked about distribution, right? So the entire setup, entire file system is distributed. Or you can think about, let's say your data source is MongoDB, right? You can even also use MongoDB as your data source, and can ingest the data from MongoDB to Spark, and you can do all those parallel processing or those things. So this is like we covered two steps. First is the setup, how the setup looks like, standard standalone Hadoop, Yarn, Apache Mesos, or Spark core. Like Spark core means the data sources or things like that. And then you have libraries, right? These, from here the main interesting things start. So how the interesting things start is like you have these four concepts, or like four things: data frames, streaming, ML graphics. So I will just brief you about all those things. So data frames is like Spark data frames. Spark data frames is like much more like Pandas data frame, but I would not say that it's completely same. But yeah, it resembles like the concept of those things, or like how you deal with Pandas data frame. You can also like make something in mind, and you can just play with those Spark data frames too. And streaming is for streaming analytics. Streaming analytics means you have like IoT sensors. If I tell you there are some IoT devices out there, like be it AC, be it geyser, so you have IoT devices fitted. So how will you analyze the things? Like it's a stream means continuous values are getting ingested. So this is for stream analytics, where the continuous values are coming in and you are just processing and just giving out the result. MLlib is the main focus. That's machine learning library. Like you do not have to make, like you may think that scikit-learn, I will use linear regression, I will use logistic regression from scikit or these things. But already Spark has those things made. Though I would not say it's very extensive, but it's like good to go. You can just go and check out the documentation of MLlib. So this is like, which is usually helpful for machine learning library, like machine learning library things, be it classification, regression, clustering. You have already defined or already made concepts of those machine learning things in your in already in the Spark library, right? Then you have graphics. So graphics is for graph processing. The graph processing is itself a bigger, like very big domain. Like if you talk about how Uber maps you with maps the rider with a driver, or like the cab driver, so this is all graph processing or things like that. And then you have these languages, right? Because step by step there is a distribution. First the distributed file storage system, then the data source, then you have different libraries which will help you. Now we got the machine learning part, right? But usually what happens is machine learning guys are like more fluent with Python, R. So you have those wrappers, right? Because otherwise, if I tell you that to use Spark's machine learning library, you have to code in Scala, you may think that, oh my god, like now I have to understand or I have to read about Scala. So to make these things easier, they had these library, like these language wrappers, be it R, Java, Python, Scala. So Spark is initially written, like Spark is majorly written in Scala. So it also requires JVM or things like that. So things go like that. So our main focus would be Python, MLlib, right? Because we are fluent with Python and we know some things about machine learning things, clustering, classification, things like that. But moving ahead, but as I told you that Spark works on the basis of parallel processing, right? So what is parallel processing? Like as I told you, like you want to throw parties to some of your friends. So let's say 50 of your friends are coming, but now for a single person or for you as an individual, it's very tough to throw a party to 50 people. So you like invited some of your relatives, some of your friends to help you out. So here what happens is the driver is you, right? Because you initiated the party and you know all those things, right? How things will work, or how the distribution would take place, or where which person would do which thing, or how things would work. So in this case, when you are throwing a party, you are driver, and the different friends or different relatives that you invited, those are workers, right? Because they are working for your instructions. You are giving instructions, they're executing it, right? So they have executors. So you as a driver tell them something to do, like maybe you just tell someone to make a pizza, maybe to make some to tell you some tell someone to bake the pizza in oven or something like that, right? You told the workers to do different things, and executors take the responsibility to execute all the things that they have been allocated, right? You would be allocating something to worker 1, worker 2, worker 3. This is how a parallel processing looks like, right? Because the single task comes through driver, right? A driver ingests all the main thing to do, and then it makes clusters. So clusters is like they have different like they divide the entire work into different clusters, and clusters then divide the work into like workers, right? Because if you do not have a central thing to monitor, right? Because how will you then see which worker is working or which worker is not working, and how will you manipulate the results of all the workers? So you require a central hub, right, to manage all those things. So workers, every task that workers do is being managed by cluster manager, and cluster manager directly interacts with the driver. So this is a brief overview about how Spark works in the backend, or how parallel processing works, right? You have these concepts: driver, worker, executor, cluster manager, right? So this is a different, like, if you want to see the definitions, or if you want to refer to these definitions at any point of time, you can just see, like, we discussed executors, right? Executors are in the worker. The workers are like, you divide, a driver divides the main function into, like, main task into different parts, and each worker is allocated some task. So driver, worker, and each worker has some executor, right? Executor, we discussed three terms. And Spark context is like, whenever you try to ingest something, whenever you try to give something to the Spark, driver has a Spark context which sets the entire base, or which sets the entire context for the like for the session, right? So this is how things look like, Spark context. And then you have cluster manager, right, which have these clusters going on, like resources, which allocate resources to each application, which allocates, like, how much storage or how much processing we should provide to someone, right? So you get those things. Like, we now have set our base, that we know how Spark's architecture looks like, and how we have the support for machine learning library, and then how we have the support for Python, right? Because Python is itself a language of much, let's say, of, like, because whenever you do machine learning or data science AI, you usually prefer R or Python. So here, like, me being a personal fan of Python, so I would be doing those things with Python, and that's why PySpark, right? So before diving into it, PySpark, how come PySpark? So we have all those functionalities in Spark, right? How Spark divides the entire task into variety of things, be it workers, be it clusters, be it drivers. So you cannot code all those things. So you have to utilize the potential of Spark. And how will we use, right? Because it's not feasible for me as a person who has been fluent in Python or R to start coding in Scala, right? So you need something. So Python as a wrapper on the entire architecture, or on the entire setup of Spark, would help you, right? Python plus Spark gives you that terminology, PySpark. So I hope that now we have a better understanding of how, like, why should we make a machine learning pipeline using PySpark. That would be covering. But now we know that we can make machine learning pipelines using PySpark, because we have that MLlib, that's machine learning library, with all the Spark functionalities and all those regression, classification, clustering things. So then we can understand how things actually work, or how things been actually going on, right? So, like, if there are any questions, I can, I can just put it out. Like, Manaprit, are there any questions?
No, not yet. You can continue the session.
Okay, okay, sure. So, like, if anyone have any queries, they can put down things, right? Even they can take note of their queries in the notebook, so that they can ask me at the later point of time. So I hope that how Spark works is clear, and how machine learning is embedded in Spark, like how things actually progress in Spark's architecture and Spark's context. You have this MLlib, right? So you have all those things. Then we will be focusing into machine learning pipelines. Then how to make a machine learning pipeline, though usually you may be aware of machine learning pipelines using scikit-learn. Like, you might have made some pipelines using scikit-learn, then you have used multiple things. But for those who do not know, or are completely new to machine learning domain, or they are just exploring, so machine learning pipeline is just a step of, like, just a set of steps which you will follow, like, to do something. Let's say you want to predict, or you want to, like, make a recommendation system, right? Because making a recommendation system is not an easy task. So you have to break the entire task into variety of small tasks, right? Because first of all, data, you would ingest the data, you would get the data from somewhere. You would then do data cleaning, because usually you might have heard that data cleaning is around 70 to, like, I would say 70 to 80% of the entire task. So making a recommendation system has these small things. Like, these small things actually add values to the entire end product. So this is how, like, a machine learning pipeline looks like. If I say that, like, you would get the data, right? You would get the data from somewhere, like, you load the data. Then usually what happens is the data is not so clean, right? The data may have missing values, the data may have null values, the data may have, like, hell lot of things, right? Like, Kaggle has structured data. Like, you might have heard that when it comes to real world, there are a lot of messy data. You do not get a Kaggle, like a data set like Kaggle, maybe, right? It's not 100% true, but yes, it's always better to know how to deal with messy data, how to deal with dirty data. So this is first you load the data, then you do some data cleaning or data pre-processing, as we say, right? Because we see how things are look, like how things actually look in the domain of the data set, or how things actually look. So you then extract the features, right? You do feature engineering. Like these two terminologies have been like very common: data pre-processing and feature engineering. So like you, these are really important, right? Because even if you do not like are not that much fluent with the high end machine learning algorithms, but if you're not like familiar with these things, be it data pre-processing, be it feature engineering, it's gonna be a tough task, right? Because these two steps, if I speak, are really important to set the base for this machine learning model to make, or to set a pipeline, right? So you just understand that how machine learning flow workflow looks like, or how a machine learning pipeline looks like. Like if you first get the data, then divide the data into training and testing set, right? Because on training data set, you just train your model. On testing data set, you just test how your model is performing. So you just first load the data and then divide, like once you do those feature engineering, do those let's say like data pre-processing and feature engineering, then you may also do EDA, right? Exploratory data analysis, to see how your data is distributed, or how things are actually working. So you can just go and check about it, like how things are actually working, or how things actually work. Then you extract some features, like we get some important features which really contribute to the models, like models performance or models accuracy. Because maybe if you do not select the perfect feature, or maybe if you do not select the correct features, important features, you may miss some important values out of it, right? So you can just extract the features and then do your machine learning things. Like machine learning, whenever I talk about machine learning things, it's like you have multiple algorithms out there, be it linear regression, be it logistic regression, be it any like clustering, classification, decision trees, naive bayes, anything you want to add. Like you can just train your model using those algorithms. And then once you make a model, once you train a model, you would love to see how things are working, right? How things are working on an unseen data set, like which the model has not priorly seen, or like which the model was not trained. You try to see how the testing works, or how things would actually work. So sorry. So then you would talk about like fitting and transform, right? You might have heard about fit and transform. So fit, transform, things are like usually very common when you come into machine learning, like fit, transform. So like if you see that in the left hand side, there are few terminologies, right? Data frame, transformer, estimator, evaluator, right? So data frame, we can just get an idea about what data frames are. Like they just store the values, like you load the data. Like I will just give you a context of from pandas data frame. You just load a data from CSV, you just make a df, right? Like the pd.read CSV, you just make a df. That's data frame. And then transformers are like you transform the features, you transform the like you do some pre-processing, you do some feature engineering, you transform those, like you transform the features, you transform the data into something on which the model can be trained, on which you can get something out of it, right? So this is like transformer we covered. Then estimator is let's say like the definition for estimator is like you made certain things, and then you want to impose a machine learning algorithm, right? Like how algorithm, like in estimator stage, you are training the model. So training the model, in order to train a model, you have to use certain algorithms, you have to use your innovative mind, right? Which algorithm to use, or whether we should do unsampling or not, whether we should do other procedures or not. You get those things, right? So estimator is like you just try to add algorithms, or you just try to impose algorithm on that data frame that you got, which you have transformed, right? Because transform, we would be at a better position to understand when we go into example after this, right? So this is how a brief overview, or this is how a machine learning pipeline looks like. I would appreciate if you can just take a note of this and can just make a pipeline, like make a diagram of the same thing. Even even I will be sharing the slides with ADM Surat team, so that you can get the slides from there and can refer to it at a later point of time. So this is how a bare bone Spark machine learning pipeline looks like. Load the data, you just transform, like transformation means you just extract features, do feature processing, like data pre-processing and feature engineering, things like that. Then you try to impose some algorithms, then try to play with some algorithms and implement it on a, on a model, right? You train a model, and the evaluator is like these, they evaluate, like maybe you have certain things to evaluate, like RSME score, like root mean square errors, and let's say you have accuracy, you can just check about those things, right? So evaluator help you to evaluate how the model is performing or how things are actually working. You can get an idea of those things from here, right? Like this is like these things, four things you should keep in mind: data frame, transformer, estimator, and evaluator. Like evaluator, even you may use certain libraries to evaluate, or even PySpark has this evaluator thing going, like evaluator thing already made. So this is like a definition if things have not been cleared yet, right? So data frame is like Spark SQL, like you heavily use Spark SQL. Maybe like you can use SQL statements, right? You can just make like, because this is the beauty of Spark. Like you can use SQL statements to query the data, to make new data frames. Like you want to get only those data where location is Delhi or where the location is Surat, right? So you can just make a filter, right? Make a filter out of it. Even you can do that through pandas data frame too. But SQL, like SQL is itself a skill set for a data scientist to have. Like even if you are very good at machine learning, or even if you are very good at data science algorithms, if you have these SQL skill sets in your bag, it's definitely good to go, and it's definitely like a cherry on the top. Then you have transformers is like one data frame to another data frame. Like when I say one data frame to another data frame, maybe like you do one hot encoding, right? Like you have different encoding techniques. Machine learning models do not understand those text, right? If you tell it Surat, Delhi, Mumbai, Hyderabad, things like that, maybe the model may not understand that much. If you have to give that in a numerical format, so you can just encode it. Let's say for Delhi it's 0, for Surat it's 2, for Hyderabad it's 3, maybe things like that. So you just transform your data frame. Like data frame is the, and like the original, let's the original data set is loaded in a data frame which have the values like city, Delhi, Surat, things like that. You just transform those things into numerical values, 0, 1, 2, 3, where 0 have certain meaning, like 0 for Delhi, 1 for things like that, right? You just transform your model, like transform your data set into these like into these, let's say, encoded values, right? Then you have estimators. Now as you have made the data frame ready to be fed into a machine learning algorithm, or to fed it into a machine learning model, you can just see, or you can just try to experiment with those things, right? How you can add some machine learning algorithms on your data frame that you have now. Like you, once you apply those machine learning algorithms, you just produce a model, right? You just produce a model on that, like how things would work. Let's say you just encoded the values, and then you just made a linear regression, or just made a logistic regression model. Then like this is an estimator is a learning algorithm, like any learning algorithm, maybe it's a machine learning algorithm, any algorithm that you take, it just trains itself on a data frame and produces a model. And then you can use that model to infer something at a later point of time. You can predict something out of it, or you can do something out of it, right, at the later point of time. Because it's not feasible that every moment you want to predict something, you are just trying to train your model, you are just trying to do everything like at that point of time. Because in real world the latency of products are really fast, like is really required to be slow, right? Because when you, if I consider, let's say you are doing a fraud detection, like credit card fraud detection. If someone swipes at a certain point of time at certain machine, right, they just swipe their card at certain machines, and if you take 15 or 20 minutes to just train your model, then just give the output, then the case is gone, right? Your machine learning model is not serving values, right? Because the fraud has already happened. So in real world you have to be very fast. So how do you training the model on go, like you have different things like transfer learning. These are complex things, not like these are not things for a beginner to be covered at this point of time. So you definitely have those things too. But like usually what I want to convey is, right, the real world application have a very less latency, right? You cannot take 5 or 10 minutes to just give some results. It should be quick, right? So that the machine learning model adds value to the business. And combining all those things, transformers, estimators, you just make a workflow, right? Here is the workflow that a typical Spark machine learning workflow looks like. Even if it's not Spark machine learning workflow, you may use this workflow whenever you use a pandas data frame to make a machine learning model, or whenever you use certain different things, right? Because this is the step by step way how a machine learning model is made, or how you do things with machine learning, right? Load data, extract features, feature feature engineering, data pre-processing, EDA, then you make models, and then you deploy it to real world applications. And like, even after you deploy that in a real world application, you never know how the data behaves, or like how the model behaves. You never know, right? Because then things may go like it's a black box. You do not know what is going on in the inside. That is when explainable AI comes into picture, or things like you have certain things into this domain. So you may have to take care of all those things, like how your model is performing in the real deployment, or how your model is actually predicting things, right? Because maybe the actual value is 100, but your model is predicting 2000, right? That's a huge difference. And you have to then see, like, did I miss some features, or did I do anything wrong? So you have to look into those things. Maybe you did something wrong in the data cleaning part, or maybe you did something wrong at feature engineering part, or maybe you just missed something when you were doing those dimensionality reduction or things like that, right? So you have to take care of all those things. So this is a bare bone machine learning pipeline. And this is like, we are talking about transformers, estimators, right? If you see in here, the second and third definition that we have are for transformer and estimator. And in this diagram here, you see that the second and third again is transformer and estimator. But what actually is transformer estimator? Though we discussed it through a definition, but it's highly important to know, like, how actually things work in transformer, or how actually things work in estimator. So this is like a visual representation, right? So how things work. Then you, like, first of all, you just get the input columns and output columns. You just divide, like, the column that you want to predict. In this case, let's say if it's a binary classification, you want to predict whether it's a fraud or not. So you might have a column, let's say fraud 0 1. 0 is for not fraud, 1 is for fraud, right? You may have those kind of things. And then you have other parameters, maybe the location, maybe the time, maybe the number of swipes that the person is doing in a day. You can have all those parameters and then make a perfect data frame, right? You can just make a data frame and then transform it. How you transform it? Like the location is Delhi, like as we discussed, Delhi, Surat, things like that. You just transform the model, like transform the data frame and just encode the values, or you just clean the data set, or you just did some feature engineering, removed some features or dropped some features which were not adding values, right? You just transform all those things. But the machine learning model is not made yet, right? Because here you just get a new data frame, right? Because here the machine learning model is not made, because machine learning models require a certain base, right? Certain data base, certain data format, right? You cannot give garbage to the machine learning model. If you try to give garbage to the machine learning model, it will throw garbage definitely, right? So you just have to encode the things. You have to just make sure that all things fall into place so that the machine learning model can train itself on it, right? Then this is how a transformer looks like, right? New data frame, things like that. But it in transformer, you do not have anything about like model, or you do not make any model out of it, right? But in estimator, if you see, you now have a data frame, and then you just try to, like, now you have, like, once you have added transformers, or once you have done those things on the bare bone data frame and made a new data frame where the encodings or feature engineering have been done, you just make a model, right? You just may build a model using some algorithms, be it linear, be it logistic regression, be it decision trees, anything, right? You just make a model and then fit that, like fit transform. We have heard those things into scikit-learn too. Then we fit those data frames, and then we try to test it, like we then try to test it on, like, how things would work. And then we make a new data frame. Like, data frame is like, because you want to predict something, you will get the values from there, right? Because model would return something to you, model would return certain values. You just store those things in a data frame, and you just publish it. You just throw it through JSON, you just throw it through let's say Flask APIs. You just do it those things, right? So this is you will get a better idea what I'm talking about, right? This is like the red box that you see. It's the pipeline, how a machine learning pipeline looks like. you first load data, right? Loading is like you just load data. Maybe like you can add certain steps in this pipeline, maybe stage 0 or stage 0.1. You can add those stage where you do data cleaning, where you do data pre-processing, things like that. You can just add all those things in pipeline. Then once the data is like good to go, there is no null values, or you have just imputed all those null values with certain things, then you can do some indexing. Even in coding you can do some encoding, things like that, right? So stage 1, stage 2, stage 3, you can add as many stages you want. Maybe you can do vector assembler, you can just add vector assembler, you can just add multiple things into this pipeline, right? Because this is from how a bare bone data set can be transformed with feature engineering. How you drop features, how you make new features, how you tune your hyperparameters, or how you do those things, right? You just and package those things. So timeline pipeline is just a package. You just set all those small parameters. You set all those small actions into a pipeline and just combine it and just give that pipeline to a model, right? On this is how the things would work. Provide me data, my model would work, like my pipelines would work, do feature engineering, every other stuff, so that you do not have to call a function every time, that go to a vector assembler or go to string indexer or go to one hot encoder. You do not have to take care of all those things. You just code it once and just make a pipeline. That pipeline would take care of this. After stage 1 is done, it would implement stage 2, then it would implement stage 3. Things would go like that, and then after that you would get a transform data. On this transform data you can just add linear regression, logistic, then anything, any algorithm that you want, provided that that algorithm suits your business use case, right? Because when it comes to like you can put any algorithm. It should not be the case that it's time series problem and you are putting certain different things which are not adding values, or which are not adding values to the model end model prediction, right? So try to figure it out, because making a pipeline is a task itself, a big task. But understanding that once you get this transform data, once you get those pipeline done, how which model to choose or which algorithm to choose, right? You have to take care of all those things, because this computer doesn't know anything, right? You have to explain to it, right? At least do those things. You do not have to tell them that do this. You can just tell a high level overview that this is the vector assembler part, this is one hot encoder. After one hot encoding is done, do vector assembling, do those things, and then the final model will be made, right? And choosing the right algorithm is itself like it comes with experience, right? You just do some small projects of your own, you do certain things at your own, you just make things like that. So this is like explanation of how this diagram could be converted into a code. This is provided when we are using the already existing functionalities, right? Already existing functionalities means you have string indexer, one hot encoder estimator, things already made into PySpark machine learning library, right? You can just import all those things. Import like I have given some links at the end of this slides. You can just refer to those resources, and you can see how string indexer, because whatever thing you see in orange are already existing through that libraries. I have imported those things by import by PySpark.ml, things like that, right? So this is already existing things. Then you put the input columns, the on which the actual model, like the on which the actual this transformation would take place, right? Because you give an input column on which the transformation would take place, and it would give you an output column. Like in stage 1, it's like on category 1 column, it would just string index and just give you a new output column, that's category 1 index. Then you can have a stage 2 where you would be having, when you where you would be doing string indexing on the column 2, like category 2, right? So category 2, again you have output column category 2 index. Then you have one hot encoder, like maybe like the in stage 2 you get a new column, right? That's category underscore 2 underscore index. You can just use this as a input column for your stage 3, and you can encode those values, right? Then you have the like you apply one hot encoding on those on that input column, and then make a output column, that's category 2 OHE. So OHE for is for one hot encoding. You can just make a new column, right? And the setting up the pipeline, right? You just see that pipeline is equal to pipeline, stages is equal to stage 1 2 3. What this means is, first stage 1 would implement, then stage 2, then stage 3. You do not have to call string index, you do not have to call everything at like every time, right? You just give a pipeline, this is the flow. This is how the things would work after stage 1, stage 2, stage 3, right? You just give a complete package of those things and set it up in a variable, right, pipeline. You can thus then fit the pipeline model, right? Sample df is the data frame that you have. Maybe you just get the data frame from any data source, maybe it's a csv, maybe it's from mongodb, maybe anything like that. You just fit the like fit on that transform, like fit on that data frame. And then you just make a pipeline model, right? And then you just transform it, like fit transform. You may be highly proficient with those things if you are using scikit-learn, things like that. So this is how a pipeline looks like if I talk about it, like pipeline stage 1, stage 2, stage 3. And like you can define, it's not necessary that one like this should be the name only, stage 1, stage 2, stage 3. You can name anything, a b c, but it should be like naming variables in a understand, like in a quite intuitive manner is itself a big challenge, right? Because if let's say you just coded something and left that company, after some day a new machine learning guy or data scientist joins the company, so how would they figure it out? Like, so it's always better to name the variables in a better position, or in a better intuitive way, so that anyone can get an idea out of it. This is how a pipeline looks like. This is like the architecture, like the things start from here: loading data, extracting features, then you train the model, and then fit transform. This is the definition of all those things. And this is a graphical representation of transformer estimators. And this is the pipeline. You could just package all those things, like stage 1, stage 2, stage 3. This is like I have tried to depict this diagram through a code, that string indexer, one hot encoder. Then you set the stages for pipeline, provided that these, you are not defining yourself any function, right? You are just implementing import PySpark.ml, things like that, right? You are not making any custom things. But that's a next agenda, that how you can make a custom thing. You want certain things to be made, you just want to automate something, how you can set those things into pipeline. So this is how the custom functionalities, like you can add custom made functionalities. Because now, before it, we just explained the existing functionalities, how we can implement or how we can use the power of the existing functionalities which are already existing, the features, the functionalities in PySpark, like one hot encoder, string indexer, things like that. But maybe in real world you have to make certain custom made things, right? It may be according to your, let's say, according to your business needs, according to your different, like according to your different, like it may be anything, right? Maybe from business use case, maybe from database, or from the data frame that you have, you may have to add something from your own. Maybe you have to use regular expressions, right? You may have to use certain things like that. You may try to add all those things into a pipeline too. So this is basic rule of, like you can just make a custom transformer, right? Because this transformer is already made, right? Because you are just adding, well, like you are just importing things and just doing things with it. But how, if I tell you that do this thing or do this specific thing, for this there is no already existing value, or there is no already existing functionality. So you have to make a transformer, right? In transformer, what we do, we just transform the model, or we just transform the data set. So the first specific thing is like implement the transform method. So like transformer is itself a class. So you can just like import transformer from PySpark SQL. And then you can specify input column and output column, as we defined earlier too, right? Here you also have input column and output column, on which columns you want to provide the inputs, and on which column you want to provide the outputs. Then you accept a data frame as an input and return a data frame as output. Like how this data frame works, like in transformers, what we do, like we do some string indexing, we do some encodings, we do some things like that, right? Transform data, right? And you get the data, set it, like pass it through a pipeline and get the transform data. So this is like how a custom made transformer should look like, or this thing, or this is the way how should we move ahead. So this is how things work, right? If you see that I have imported from PySpark.ml.pipeline. So you have to implement it, right? PySpark.ml.pipeline. It tells the, like it, while you are executing this code, it tells that you have to execute a pipeline, and you are importing transformer. So transformer gives you the flexibility that you can make some different custom made things. And make sure that if you see there is a class my word counter. So in real world use case, you may want to count some words, or maybe you want to count how many, like it depends on your use case, right? In my case, I have just made a my word counter, like how many words I have in a specific file. I just in the second line from the top, you have transformer, and then you have in has input column, has output column. I just inherited those things. And the first two functions that you see, like the first thing that you see, def underscore underscore init, you have to add these things, right? Because otherwise things would not work. Because I have tried to use things without these two, but it's a huge like headache to do all those things. So you can just use all those things, like the first two functions. Then you have like def underscore transform self data set. So self is like constructor thing like that, output column and input column. Then you define your transformer, right? You just define your transformer, that like logic, you just define a logic, that this is the definition. Like whenever you have function return s dot split, so maybe whenever you want to count the words, you just divide those words on the basis of the number of spaces you have in between, right? So you just split those entire word or entire file on the basis of the spaces that you have. Then you count those things, right? Then at the end, like after you have defined the entire class, so class my word counter is a transformer, right? A custom transformer that I'm talking about. You can talk about anything that you have. It depends on your business use case. You can define variety of things, be it data ingestion. You can also ingest your data through this, or you can ingest every, like you can do every, like you can just also add some machine learning models into it, in order to make it more intuitive, in order to make it more easier for the beginners with PySpark. I have just added like a small section, right? And in the last line, if you see, WC is equal to my word counter, input column is equal to review, and output column is equal to WC, right? It would take the input column review, and WC would be like, it would be giving, like let's say we have a file where each row is a review, right? Like let's say it's Amazon product. You have, there are reviews for every product that they have. And then you input those column, input that column, review column, into your transformer. And you want to check how many words are there in that review. It will add a new column, output column is equal to WC, right? In WC, that's word count. You can just add, like my transformer would work and just count my number of words using split function, using variety of things that I have defined. Or you can just add like a variety of things at your disposal, right? Whenever things work, or whenever things you want, you can just add those things, and you can get output column, right? So this is how a custom transformer looks like. So a brief overview about what we covered is like how Spark's architecture will help us in doing machine learning, right? We just discussed how the Spark architecture would help us, right? The libraries, the languages, the Spark core, the data sources from where you get the data. Then you have this distributed processing. Then how actually distributed processing works, or how things happen, right? Driver, worker, executors, you have those things, the definition are put here. Then we just try to understand how a machine learning pipeline looks like, and how we can make a machine learning pipeline with the existing functionalities. So this is how a machine learning pipeline looks like, even with Spark, even like in the normal context. So this is the transformer, estimators, pipeline, things like that. Then we graphically saw that how transformers, how estimators work, or how things actually happen, right? Then you have the pipeline, and I just try to transform it into a code. Like it's like custom, like it's already existing functionalities. You can just import PySpark.ml and string index, things like that. You can just import those things. So these are already made, but in case in real world you want to add certain things from your end, or your business use case wants different thing, or your business case want certain variety of on variety of things to be added. So how can you make those things? This using custom made functionalities. And then you have like how to make a custom made functionality through a transformer, implement the transform method. Like that's inheriting the transform method, specify input column, output column. Because in our case that we have, like we put the input column as review and output column as word count. Then you accept a data frame and return a data frame. Like our data frame would be, the final data frame that we have would be having review and output column. So we can just utilize that whenever we put a new value, whenever we have new reviews there, our model would work, or our pipeline would work, and it would give the word count, like the number of words in that review. So this was a high level overview about how you can make machine learning pipelines using Spark, be it already existing functionalities, or be it you can use your own custom made things or custom made functionalities to do those things. So these are a few useful resources. Those who are just starting with Spark, You can just go to the first link, spark.apache.org, and then you have building machine learning pipelines analytics with their blog. Then you have multiple variety. These are the blogs that I find are really useful or will be really helpful to make some machine learning pipelines for your day-to-day tasks, or maybe for your experiments, or maybe for learning things, right? So like, maybe it's like you may talk that Spark is a different domain, or Spark is different, things like that. Like Spark is a huge thing out there, or how Spark works, like how Spark works, because Spark in the real in a past few years have been via big data terminologies. Usually data engineers, or usually data engineer peoples have been using it, right? So this is how like Spark has progressed. But now as machine learning is picking up pace, so they have now integrated those things, and they like hell lot of things are being added, and variety of machine learning concepts or machine learning libraries, machine learning algorithms are being added. So this is because this is an open source project, you can definitely learn, and you have a variety of things out there, right? So I think that it's done, and if you have any questions we can just like ask.
Yeah, so like two like people are saying like your session was very good and they really liked it and they've enjoyed it, but they found if you could do an actual implementation and show them like some code or something.
Something like, because if you want I can just do a hands-on session around 30 minutes after like in this coming week. If they want, right, I can just do a 30 minutes hands-on session doing a spark PySpark machine learning pipeline, right? Because I can just help them code like how things actually work, or how we can, because now I have just made those things through a blog, like through this image, right? Because they may not be able to see how things work, or maybe they are not able to see like word counts, how this word count is working, right? Because I will, or what I can do is I can just make a Jupyter notebook, and I will share it with the
Yeah.
Surat team, and you can just send that Jupyter notebook to these attendees, and they can just get idea from there. And if in case they have any like in case they have any doubts regarding the Jupyter notebook that I sent, they can reach out to me, right? They can reach out to me over, like, over my email ID, or like GitHub, LinkedIn, anywhere. They can reach out to me, and I can just be happy to help them out if they face any difficulty in the Jupyter notebook that I sent.
Okay, so there's just one question for you. Could you explain logic in the custom transformer code?
uh, this one, like I hope
Yeah.
that that person is asking. So logic is actually like, it's a keyword type of thing. You can just define those things, like what logic you want to do, like how would the computer know, like how would the computer know if you, I have tried removing that logic too, it works well. But it's like logic, I just tried to the C, right? Because I was just learning. So without logic you can also do, it's not that with logic only things would work. Or you can just define a normal function too, right? Def f, like you can define any function normally, and even if you remove that logic it would not be a big problem, right? Yeah.
Okay. So, like, I had some few questions for you.
Hmm.
Well, like, how did you motivated to start to contribute to the community by organizing these meetups, and how was the journey in this Kaggle?
Yeah,
Tell
so
them.
like my journey would be like, I started my machine learning or data science journey in October 2018, like to be precise, from October 2018. So like from then onwards, I have never paid a penny, right? Because I have never paid anything to buy a course. Or because if you see, I do not have any Coursera certificate as such, right? Because I just audit the course and keep on going, right? But then I thought that if I'm not paying, so I should pay back in a different variety, right? Because if I'm not paying the, because if you're using Python, that's the hundreds of years. If you go, it's a hundred of years of efforts. So like you can just go and see like how things actually work, or how things actually do, right? So like I have to pay back, right? Because I'm not paying anyone. I am using open source community things, right? If you talk about Kaggle, if you talk about Python, if you talk about any library that you use, even PySpark, even if you talk about Spark, so these are all open source. So it would be unfair if I do not give back, right? So participating in communities and organizing meetups or organizing events or connecting with people is just a way to give back, because I cannot give back directly to the community, right? I cannot directly give back to Spark community that take 100 rupees, or because I can I would not love that, right? So I just try to motivate myself that as I have learned from the community, I see that Abhishek Thakur has joined. So so like
Yeah.
big motivation himself. So right, because you see the community has been giving a lot to me, right? If you see, like, be it YouTube videos, be it blogs, be it anything, so it's my duty to pay back. So this is my journey to get motivated. So how to commit back or how to do things. So then, like, from October 2018, I learned from free resources. Then I tried to make resources free for others. So that's the only goal.
So, like, what is one advice to your people who are beginner in this field or just converting from software to data science and beginner
Um,
in this field?
my suggestion would be that do not skip the basics, because usually what happens is, because just because your friend is posting about deep neural networks, your friend is posting about GPT-3, because I have not used GPT-3 yet, right? But because I have heard from my friends that, oh my god, Ayon, someone posted about GPT-3, I should also do that. So I would always suggest that it's okay to go slow. It's okay to understand the maths first. There is no hurry. The data science domain is not going to end soon. It's not the case that if you start slow, or if you go understanding the basics step by step, there is no any hurry that the data science domain would go and you would miss a lot of things, right? Because if your basics are strong, even if GPT-3, GPT-5 comes, you are always in the market, right? So always
Yeah.
focus on the basics, and do not try to import everything, right? Because even import star. So I just could not remember from where I heard about those things. Like, importing star from those things is not a good, like, I would not, because though it makes your task easy, but it's not a good approach at the beginner stage, right? Because, right, it's not, because you just miss those things, like linear regression. If you just implement, like,
Yeah.
from scikit-learn linear regression, you never know, like, y is equal to mx plus c. You just know those things. You do not know slow. You do not know those things. So I would just appreciate if, even if you start slow, it's okay. Do not be in the hype that data science is this thing, data science is this thing. Oh my god, I am doing linear algebra and GPT-3 is coming. So do not rush behind that thing, because it used to happen with me as a beginner too, that I used to see, oh my god, computer
Yeah.
vision, NLP, it's a overwhelming thing, right? It's a ocean. It's not
Yeah.
it's not a lake, it's a ocean. You may get drowned. So just step by step, take your like self safety jacket. And safety jacket in this case is like the basics, the maths
Yeah,
basics.
like I think people generally feel like the other person is doing so good and I'm just lagging, so they jump and jump, and sometimes they just implement some other's code and thinking they are very good at it, but they ignore the basic maths. Like even in linear regression, like as you said, the
Mhm,
simple equation is y is equal to mx plus a. Okay, so this is the line of an equation we learned in our 10th, 11th,
mhm,
11th maths. Yeah,
mhm.
so like even in NLP, when you make a language model, it's basically a conditional probability. Given a word, predict the next word. So
Yeah,
that
definitely.
conditional probability, like sort of, it's a basic that we learned in our 11th, 12th maths. So like mathematics play a very important role
Exactly.
in
So
data
my
science.
journey also started from there only, because whenever you try to get into data science or machine learning, everyone speaks to you that you should be at least having a sound knowledge of mathematics, right? So you
Yeah.
should get something out of it. But like, I had that, even it was a fake thing, that thing, I don't know, because I scored 98 out of 100 in class 12 boards, right, in maths. So I had that confidence that I can just move ahead. Indian mentality, right? Like 98 out,
Yeah.
98 out of 100, I can just go and rock the stage, right? So I just had that CBSC wala push, that 98 out of 100. And then I tried to do math, and that mathematics has really helped, right? Because I would
Yeah.
have been lost if I have not done mathematics. So, like, I devoted around 1 or 2 months just to understand the maths, though I was slow.
Yeah.
But my friends were doing linear logistic. Even then, I was not aware of these algorithms, right? So
It's
now
okay
there is a
to
big
not
difference.
be aware. Yeah, like I feel like data science is a field of being patient, learning, being patient, and exploring and researching and reading blogs and
Yeah,
like
reading blogs. Yeah.
readings and patience is a very important thing value in data science. Well, we have a question for you. Can you share some good resources to learn the maths behind ML algos?
ML goes three blue, one brown.
Okay. Yeah.
So go
Okay.
there, and like even you have some good resources out there, like three blue one brown is definitely like my go-to place whenever I'm stuck. Like super awesome videos and soothing one, right? The work that he has done, that the YouTuber has done, is definitely awesome, and you can just go, and you have mathematics part by MIT and things like that. But I would just appreciate start with three blue one brown. You would just get a brief idea about those things, and then you have variety of like awesome YouTube videos out there, right? Like be it anything like Abhishek, Krish. So they have awesome variety of concepts coming in, awesome variety of like you to keep updated. You can just follow them, right? They have awesome things keeping going on, and be a part of communities, right? Manpreet started this community in Surat. So like once this pandemic gets over, try to organize some physical meetups and try to grab
Yeah.
some
Yeah.
free
Sure.
pizzas and cokes. So that's definitely a
Yeah.
learning
Uh,
booster. Like learning with pizza in hand is a different
Yeah, actually, I
thing.
started it in Surat because, like, my college is in Surat. Like, I'm from
Mhm.
NIT Surat, and I believe that I realized that people are not much into tech here, and so it would be good teaching them and letting them know like, how the things have been advanced and how things are being done.
Yeah, you
Yeah,
took the responsibility, right? So it's
yeah,
time to
like,
deliver.
yeah, and I feel like so lucky that Abhishek Thakur sir is my alumni.
So even you
Well,
joined your meetup.
yeah, it's
So,
all because of you. Well,
so
let's,
thanks to all of you for joining. Thanks to all of you for joining, and
yeah.
thanks to
Any
KDM
end note
Surat.
you want to say? End note to the viewers and the listeners.
End note is like do not be overwhelmed with these terminologies. Like you may think that these are very big things, or these are very big things going out there, so do not be overwhelmed with those things. Start slow, and like there is no any harm in starting slow, but make sure that you do not remain slow, right? Start slow and go slow, it's okay, but someone may convert this message into like start slow and be slow. Not be slow, start slow and go slow, right? Maybe like like be a turtle, right? Because you will learn a lot in this journey, and you may not get those things from a book or from blogs. Maybe if you do self projects, my first focus is, even if you do not do Coursera courses, I would just appreciate if you do personal projects from wherever you do, be it, but do not copy paste, because there is a crazy thing going on, right? They just copy paste the code from someone's GitHub and just claim, just change the variables, just change everything, and they tell that it's their own project. So do not try to do that. Go slow, take 15 days, take 20 days to do your project, but do not be in a hurry that I should be making 5 projects, I should be making 13 projects this in this time span. So do not make that hurry. Like, and be a part of this community, right? Be a part of any community which adds value. So this will definitely help you out in the coming time. And Surat is gonna get a new face for data science, I hope so. And one day if I come to Surat, maybe I can just in a physical meetup.
Yeah, you're welcome anytime. And thank you so much, everyone, for joining us today. And we'll be back with another meetup soon next weekend. So stay tuned. And this will be on this channel only. So stay tuned. And I hope you have a great Sunday ahead. Thank you,
Yeah,
Ayon, and thank you, everyone, for joining
thank you,
us.
bye bye.
Bye.